Hello everyone, welcome to this month's edition of the ChiPy main meeting, first meeting of the year. I'm going to go through a little bookkeeping here, and then we have two great speakers for you tonight. So, again, welcome to the main meeting for January 13th. Like I said, just going to go through a couple of bookkeeping items here. First thing, we do have a code of conduct for the Chicago Python organization. Basically, just treat everybody with respect. If you have any questions about that, this is the link to go look at the code of conduct on chipy.org, or feel free to contact us in any of the ways that I mentioned later in the presentation here. We have a new sponsor this month. Spot Hero recently is sponsoring ChiPy at a gold level. They're joining our other sponsors, Braintree, JFrog, and Zorro. Again, this month JFrog is sponsoring a raffle here. They have a couple of fruit clues, I believe, to give away. Neat little device. You can go to this link listed here. I also set that out into the chat. I posted that a couple times throughout the meeting. Really easy to enter, just a single form to display. They'll announce the winner on social media within a couple of days, and check if you're still interested in the device and make that clear to everyone who's won. A little bit about ChiPy. We're a Python-focused community that was started in 2003. The current board members are Zach Rosenberg, Joe Jasinski, myself, Chris, Ross, Kevin, and Heather. We have several initiatives that we go through, that we try to keep moving through the year. One of those is Project 9 Web Guild. We also have a buddy mentorship program. You can find that at chipymentor.org. Kind of a neat little site that will match mentors and mentees for specific Python skills. The Python lunch break, Algo Sig, which is held every month. And then if you're interested in Python jobs, there is a job board on chipy.org that you can check out. We have several listings up there right now. The next upcoming event is going to be the main meeting in February on the 10th. If you need to reach out to us, you can find us at our Slack. You can find us on Twitter at Chicago Python, or on chipy.org. There's a contact form there as well. Tonight's talks, we have Mason A. He's going to get into everything interesting about SSH that you never knew. And then Joe is going to be talking about Mtls with Python. There's a couple other items before we actually get into the talks here. We will have a short Q&A session after each talk. If you want to participate in that, YouTube is posted in the live stream chat. We'll get those to the speakers and they'll answer those. There is a little bit of a delay for us between our platform and YouTube, so do be aware there's like about 10 seconds between when you post something and us being able to see it and enter back. And then after the meeting, we will have an after party at the chippy.town. I'd like to see you all there. Hopefully the speakers join and we can follow up on any questions there. So with that, I'm going to turn things over to Mason and let him tell you guys everything about SSH. Hi, Mason.
Hey, how's it going?
Good, how are you? You'd like to just do a brief introduction about yourself, and unless you run right to your talk from there?
Yeah, you've got the wrong slides up real quick, though.
Oh, I've got, all right, sorry.
No problem.
You're all the way over here. There we go. Great.
Yeah, my name's Mason Egger, and I am a developer advocate at DigitalOcean. You can follow me at Mason Egger on Twitter. I'm also the conference chair for PyTexas 2022, which is happening March 26th and 27th in Austin, Texas at the Austin Public Library. We hope to see some of you there. So today we're going to talk about SSH can do that and a lot of things that people don't know about SSH. So, brief outline is I'm going to introduce you to OpenSSH and SSH. They are different things. I'm going to share some commonly overlooked SSH features and configurations. I'm going to demonstrate a couple of useful SSH tricks that may get you out of some sticky situations sometimes. And we may just dive a little too deep into the SSH arcane void. We'll find out how far we get. So, let's start off by talking about what is SSH. It's probably a command that if you've ever deployed anything on a server, you've seen before, but you know, what is it? Well, SSH stands for Secure Shell. It's a protocol for creating encrypted communication channels between two networked hosts. The original protocol was created by Tatu Yolonen in 1995 to replace insecure protocols of the time, such as Telnet, RSH, and RLogin. So that's what SSH is. What is OpenSSH? OpenSSH is what you actually interact with. So it is the standard tool for remote management of Nginx-like systems, but even now on Windows, it's there too. Embedded devices, networking devices, pretty much anything. If you're trying to get a remote terminal on, you're using SSH. It is maintained by the OpenSSH community. It was originally released in 1999. For those of you that don't know, the OpenSSH community is part of the OpenBSD community, which is a BSD-based operating system. There's a lot of history there. I could do a whole talk just on that. But it's a really cool, lesser-known operating system that focuses on secure things and security, which is why OpenSSH is maintained by them. There are two different versions of OpenSSH. There's actually the OpenBSD version of OpenSSH, which is the version that has the latest and greatest features and some stuff that a lot of people don't really know about. We're not going to talk about that because I could go to a conference of 10,000 people and maybe find 2 people that use OpenBSD. But portable OpenSSH is the one that you are familiar with. So they do a lot of the testing and the features on OpenBSD, and then if the features are liked, they port them over to OpenSSH, portable OpenSSH, and that's what gets installed on your Linux environments. Happens in the OpenBSD branch and is then ported over. It's held to the same extremely high standards that the OpenBSD project holds themselves to, which is why OpenSSH is considered one of the most secure tools. I can't remember the last time I've heard about an OpenSSH vulnerability, other than people, breaking of encryption keys, which, as encryption algorithms get weaker, that becomes a problem. And then also just SSH version 1, we don't use that and we don't talk about it. And there's a dog outside, hooray. So the pieces, there's 2 main pieces. Not going to deal with that. There's 2 main pieces of SSH. There is the SSH server, which basically is it's a piece of software that is listening for connections, incoming SSH connections across, a very specific protocol, a very specific port, and then it authenticates them and provides you with a terminal. And then there are the SSH clients, which we have, which are what we use on our machines, used to connect to a remote device. There's a lot of popular clients. Windows, up until very recently, last couple of years, PuTTY was kind of like the best option for that, but now Windows 10 at least natively supports native SSH, which is awesome. So now you can use that, but PuTTY was a very popular client back in the day. Any other Nginx-like system is just using SSH with the parentheses 1 means it's the command if you look at it in the Linux man pages. So those are the popular clients. There's 2 different protocols, protocol version 2 and version 1. I haven't even heard about version 1 in the last 7 years. It should be pretty much gone from this planet. You may run into it if you're maintaining like really old network gear. Like if you got like a Cisco router or something from like the 1980s, you might still run into version 1 of SSH, and the SSH client can connect to it, but just know that it's barely more secure than unencrypted telnet. So don't really use it. By default, if you're just using it on a new server, you're going to default to version 2. You don't have to worry about it. I kind of tell people, if you're on version 1, you kind of know you're on version 1. I think even the client screams at you now if you're trying to use it. So let's talk about SSH server configuration. So it's found at Etsy SSHD config. Usually the defaults within SSH are very reasonable and require little to no modification whatsoever. And that's actually been a really great feature. Is like if I hadn't started diving deep into SSH and like playing with it, I never used to modify it before. There are a couple of common modifications though that if you are running a server on your end that you should do to ensure that no one can take advantage of it or exploit your server. One of the big ones that you'll see at a lot of cloud providers is disabling root login, just not allowing root login at all. You can make it where root can log in via key only. That's a little bit more secure. It's a lot more secure, actually. But still, a lot of people choose not to have that. You can make it where no password authentication, so you have to authenticate via SSH key. You can disable X forwarding. If those of you that don't know what X forwarding is, it's the GUI. You can forward your GUI across SSH, so that way you could actually like interact with your GUI over it, which is pretty cool. But most people disable it, don't really use it. There are a couple of other really cool things within it. You have conditional configuration-based matching. So you can do a lot of almost logic you can do inside of it. You can match by user, group, IP, or even host names. You can do something like this with a multiple match. So you can say that if I'm authenticating from this address, which this is a 192.0.1 address, which would be an internal private address inside of a LAN, and it's myself, Mason, that's trying to log in, then I will allow for him to use password auth because it's myself and because it's happening internally. Otherwise, no. So you can do a lot of different configurations around all of this. Another one of the really cool features around SSH is chroot. So if you're ever been wondering about like what is chroot, chroot is the process which changes the directory where a user logs in, and it's used to isolate and protect the system. So if I'm logging in as an SSH user, I could be dumped in like /home/Mason, and that's a pretty interesting place. It's not necessarily the most secure, but we could use this thing called chroot, which is where I can dump you in a different directory, and then I can specify exactly which commands you have access to give a much more limited access to SSH. My Labrador just came in the door. If someone in chat says they want to see him, I'll show it to you, but you have to say it in chat. Chrooting users, it is possible to chroot them. You have to set up this directory beforehand. You can't just. It's a little bit more complex. I'm not going to demo this particular aspect today. The likelihood is most people won't need it, but it is an option. You'll need setup to basically set up the directory and give it the permissions. You have to say this directory gets bash. Like it's pretty specific. And you tell which directory, which group. So if they're in a certain group, you can do that. What directory to dump them into. A lot of fun stuff. So a lot of people don't know that you can use SSH as like an up process isolation or user isolation mechanism. Next, let's talk about some client configuration. So these are some things that if you're using SSH yourself, some things that you can use to make your life a little bit easier if you have to SSH into a wide variety of machines. So user-based SSH config is found at your home directory /.sh/config. If this file doesn't exist, you can create it. And this will be your personal configurations for SSH when you're SSHing into servers. It offers host-based configuration with wildcards, with basic regex. It doesn't have a lot of really advanced regex, but it does. So say I set up all of my servers at something mason.dev, and I decide that I want to use all of them on port 2222. Now, whenever I am SSHing in, I could just do sh-p 2222, but I'm likely to forget every time, especially if I'm going between a lot. So why not just have my SSH configuration automatically do that for me? that is definitely an option that we have. You can also pass in configurations via the command line. So, and if you're trying to say the port, you could do -O and then actually pass in the direct config. This was not the best example because port is a flag, but if there are a lot of options in the SSH config that are not directly flags that you could pass in and basically change the entire way that your SSH configuration works. You can also run arbitrary commands and get the results back. So say I'm working on a specific machine and I want to run, maybe, or like I'm on my desktop and I'm maintaining a cluster of servers and I want to know what the disk space is available on a certain server. Instead of logging in, running the command, coming back and doing it, I could actually just use SSH to execute the command, and then the command would come back via standard in. And if I'm writing, more advanced bash or more advanced like looping stuff, I could then ingest that data and use it for something else. So you can run arbitrary commands, just log in, run it, and come back. This may be useful for, say, maybe you're trying to test, a piece of software and you have it like rsynching across different servers, and then like maybe you want to test it on an older version of Python and you have that installed over here. If you say you weren't using like PyEnv, or I think it's PyEnv, yeah. A lot of different things, but this can become really handy if, say, you have a whole bunch of servers and like fleet, maybe you're maintaining a Kubernetes cluster and you need to be able to run a certain command on all of them, but you don't want to have to SSH in and do all of it. You could easily just go and write a loop and run this SSH command, and then template out the host name here and run a whole bunch of commands like that. There's a lot of really cool things you can do around SSH regarding automation. So you can set up tasks to run when you log in. So you could set up, if you set up a at your home directory at .sshRC, you can basically allow people to just run whatever they want. So when they log in, maybe I want to set an environment variable when I log in, or fetch something from a URL. I can. You do have to enable this in your SSH configuration option. So this will not be available on the SSH server. You have to turn the permit user RSC option to on. It may default to on. I don't remember, but it's always something worth checking. And we have a yes, 100%. So, I can't pull that up because I don't have access. But Eric in the comments, there it is. Yes. You can also be completely insane and use a here doc to run a block of bash instead of a single command. Yes, I've seen this done. I used to complain a lot about this, but it works. Like, it works. Sometimes, this was config management before config management was really a thing. And it works. SSH is, as you can see, really awesome tool. Thanks. You can take the comment off now. The thing that you put in your SSH RC must be a valid shell script. So you have to have the bang pow bin sh, I think, or shebang bin sh at top. But yeah. So automation, you can automate things when people log in. You could do this with like the SSH, then have like a bot log in periodically to run some automation. I'm sure there are easier ways, but you do you. Okay, the next one is pretty interesting, and this is one that I've actually worked with a lot, and it's around SSH client agent forwarding. So you can, if say, this is a really interesting scenario. So say you have a whole bunch of servers behind a load balancer that are not accessible to a public internet. So if you look at this diagram here, I have 3 web servers. They're all within inside of a VPC, and there's a load balancer in front, and they're not, like, you cannot access these web servers from the public internet. I've created a bastion host or a jump box to be able to jump into these and do it. Now, the problem is that I don't want to host all of my, I don't want to have my SSH key, my private SSH key on the bastion host. Bastion hosts tend to be getting bombarded with attacks. It could come up or down. Like, there could be like an opportunity for us to, like, some people have their bastion hosts come up dynamically whenever they actually need to access it. And then also I have to worry about storing private keys. And now we've introduced a whole realm of hurt because now we have to store secrets, and maybe we didn't want to do that. So I need to be able to SSH into so the scenario is here is I have the keys to the web servers on the machine. Like, I have my key. I can SSH into these web servers, but I have no way through. I can also SSH into the Bastion, but the Bastion, once I log in as a new user, won't know what my key is. So how do I forward my identity from my personal machine through the Bastion to the web servers? And it's called SSH agent. You can run SSH agent on your local machine, and you just do the -A. So it will basically take my keys and it forwards them to the Bastion. The Bastion doesn't know anything about them. And then when I go to log in as the correct user on these web servers, it uses the keys that are stored that came from my SSH agent, and they just pass through. Those keys never live on the Bastion, but I can directly access my web servers. And that's how it works. However, there is a warning behind this. SSH keys are kept in memory. So if the Bastion becomes compromised and someone does a memory dump, they could be pulled out of memory if they know what they're doing. So kind of like take it with what you need. This is where the example of the dynamic Bastion really becomes helpful, because, like I don't like, especially say I'm running this on DigitalOcean and I'm trying to run a small startup. I have three $5 droplets in that $5 Bastion. I need to log in once every couple of days for 20 minutes to do something. Why would I leave that Bastion up just running money? That doesn't make a lot of sense. I could spin that Bastion up dynamically. I want to log in. Let me spin up the Bastion. The Bastion is there. I log in. The keys are then they're sitting there on the Bastion. And whenever I log out, then I just destroy the server and it's not there anymore. No worry about security vulnerability. That's one option for it. Okay, so now we're going to get into the demo and the fun stuff. So all this stuff is really cool and really useful. But it's kind of specific. I would say that the port forwarding part of SSH is, in my opinion, it's the crown jewel. It's the best part of SSH, of the features you probably didn't know. So SSH is really good at just taking anything, wrapping it, any arbitrary TCP traffic, wrapping it in a secure tunnel and delivering it somewhere. So there are a lot of old school insecure encryption, or not encryption, but services and protocols, POP3, IMAP, HTTP. These are insecure protocols, and we can actually secure them by wrapping it in an SSH tunnel and then doing the traffic. And it would basically, I'm trying to think of a good analogy for this. It would be if you're in, if HTTP is two people outside on the street yelling at each other, and then instead we just move them inside of a house and they yell at each other. If you're outside on the street, everybody can hear you when you're yelling at each other from 20 yards apart. But if I move them into a house, it's people won't be able to hear because we're inside the house. Creates a secure environment. We have to work on that metaphor. So there's 3 different types of port forwarding, 2 of which we're going to go over tonight, 1 of which I'm going to try to steer you away from, unless you're just feeling really ambitious. So there's local port forwarding. So it's take this port on this SSH server and make it local to my client. I'm going to demo this one live. There's remote port forwarding, which is take this port on my client and attach to the server. There's dynamic port forwarding, which basically enables a SOCKS proxy on the SSH client, allowing you any request to proxy out through the server, giving access to the server's entire network, kind of creating a VPN. We're going to go over why this is not a good idea in a minute. It's fun to do. It's not fun in practice. So let's talk about local port forwarding. And we're going to go ahead and so we take this port on this SSH server and make it local to my client. So let's do an example of this. This used to be a lot. I will say it used to be a lot more relevant in the days when you had to pay for SSL certs. There are probably people watching that never remember the days before Let's Encrypt, and you have to pay $150 a year minimum to get an HTTPS certificate so you could have HTTPS. Now, some of us didn't want to do that, but some of us wanted to run WordPress, and everyone knows trying to log into the admin panel on a WordPress site over non-HTTPS traffic, my credentials are going across in plain text. So what I could do with this is I can take that port 80/admin, or just port everything across the HTTP port, and then I can tunnel it back to my machine. And then if on my local machine, it would it would be tunneled to my local host. I could access it and log in, and that traffic would be secure because it's through an SSH tunnel, which is really awesome. So now everybody else going to my site that was trying to go to that would do it insecurely, but I can now do it securely and not have to worry about my credentials leaking. It's it was a lot more relevant when it wasn't just easy when you didn't just do certbot-auto or certbot and it just gave you an SSL certificate. We've gotten really spoiled with that, but there is still some valuable times when this is necessary because, like I said, not all protocols are secure. Also, fun thing about this, maybe you're trying to get to a port that isn't really allowed. SSH bypasses almost everything. Like, most people can't block SSH on their IT network, but in reality, if you allow SSH on your IT network, in theory, everything on your entire company network could be taken. Not through security and vulnerabilities, through the one I'm going to show you next, which is remote port forwarding. But let's talk about local. So we basically do an SSH dash. That looks wrong. That is wrong. It's the one at the bottom. It's the dash L here. Dash L, we take the local port, and then we have our remote destination and our remote port. So I'm going to say SSH-L on port 8080 on my local machine. I'm going to go to chippy.sammy.cloud, which everybody can go to. It just says Chippy. And I'm going to forward that port 80 to my port right there. So let's go ahead and do that. SSH-L, it's uppercase L, correct? Yes. We're going to do port 8080 : chippy.sammy.cloud, port 80. So I'm, again, 8080 on my local machine is going to have port 80 on chippy.sammy.cloud forwarded to it. And then we're going to do root at chippy.sammy.cloud. Hopefully I did that right. And there we go. You don't know it. You don't know it worked. It doesn't really tell you. If it didn't work, there would be like a little teeny tiny message up here that says that port's already in use. But it just looks like a normal SSH connection. So now, if I come over here and I do local host : 8080, I can now see Chippy, hello Chippy, and I'm not running that. So just to prove that I'm not running that, let's go, like I'm not running that locally, var www html index.html. Come on, we can do it. And I'm just going to put live edit. And if I go back over here, it's working just fine over here. And if I go over here, it's working fine over here too. So we have taken a remote insecure port, and now I can access it, and it's through a secure tunnel. No one can see what's going on, and now I can do whatever I need to do securely. And that's very, very valuable. Like I said, it was a lot more valuable back in the days when HTTPS was difficult to come by. But even still, maybe you don't want to set up HTTPS for some reason. I assume there may be one. I can't think of it, but I assume there may be one. Or more likely, you're dealing with a port that's not a secure. You're dealing with a non-secure protocol, and you want whatever you're about to do to be secure. So that's one way to do it. You actually could technically do this with Telnet. Say you had to Telnet into something, and you had SSH access to it, which I don't know why you'd have to Telnet if you had SSH access. You could secure it. Anywho, that is local remote. That is local port forwarding. Oh, great. My notes went away. That's fine. I know what I'm talking about. The next one is probably one of my favorites, which is remote port forwarding. So with remote port forwarding, it's the opposite. I can take a local port that's on my machine, and I can map it to chippy.sammy.cloud if I have SSH access. So say, this is a great example, because say I'm working on, okay, so let's exit out of here and let me pull up some code real quick. Come on, computer. Code. One second. Okay. I go to localhost 1313. This is my personal blog site, okay? Like it's a Hugo site that I run locally, that I build, and then I push up and it gets deployed. So say I'm doing something for a client, maybe I'm a consultant, and I want to show them what I'm doing, but I don't want to host it on a server, permanently. I don't want to be working on a server. I want to work on my local machine. But how do I share something that's on my local machine with my client? Well, with SSH Remote Forwarding is for. So if we take SSH Remote Forwarding, we can take this 1313 and host it on any port we want on Chippy, on chippy.sammy.cloud. So it's SSH-R 8000. We're going to do 8000. And then we're going to say on my local host, we're going to port forward 1313. So my local host is now available. So now anybody in the chat right now could go to chippy.sammy.cloud and go to port 8000. I hope it works. It's not working. What did I mess up this time? I messed this. I had so much trouble with this last time, and I don't know what's going on with it. That's right. Always test your demos beforehand. I tested this a day ago, and it worked, and I thought I had it. Let me make sure. Connection refused. I think I know what it is. Okay, so we're going to do a little bit of quick debugging. If I don't get it immediately, you're just going to have to trust me that it works. There's a setting in SSH deconfig, and I didn't think it mattered in this instance, but I could be wrong. I don't remember what this. I remember what it's called. Allow agent forwarding. No, it's gateway ports. So it does. If by doing this, I would have been able. I think this is it. We're gonna allow gateway ports, and we're gonna say yes. So what this does is, I think SSH does attempt to prevent you from actually accessing it. For anybody to be able to access it, like I would have been able to go on my root ChiPy, and I would have had it mapped, and I would have been able to see it if I'm on there. But if I want the whole world to see it, I believe I have to enable this systemctl restart sshd. Okay. Now let's try it. If it doesn't work, then I'm a liar, and we can all just try again another day. Is it still running? It's not running on my local machine. And now it's working. That's what it was. It was that config. I forgot that config. I've got to write that in my notes. Thank you for being the first time I've given this talk in a while. You have to do that enable gateway ports. If you don't, so what it did beforehand is, like, if I had I could have gone to my IP address internally on that server, and I could have accessed it from there. Only on chippy.sammy.cloud. But because I do this gateway ports, now I allow for everyone to do it. I actually had a really cool real life scenario where we were using this. I was playing Dungeons and Dragons with my friends, and one of them was the host, and we use a Java tool called Map Tools to kind of like create the maps and walk around, like, you know, do all the stuff. But they couldn't get port forwarding to work on their local machine, like their local internet at home. Did I have gateway ports here in the thing and I didn't even listen to my own advice? I did. Anyway, we were trying to do it, and they couldn't get port forwarding work. No matter what, we couldn't do it. So I was like, let's just use a remote tunnel. So they started up this server, which ran on like port 51234. And then we did an SSH remote, and then everybody in the party connected to that. And we could connect to their tool that was not web-based. Like it was a, you know, not my web-based, I mean, not HTML, not HTTP. It was a, you know, tool that runs on this machine that outputs a port that people can connect to on a LAN, and we were able to forward that LAN port across. So that was pretty cool. I really enjoyed that. Okay, so that is what we have for remote forwarding. A couple of other things. There are two things that I'm not going to have time to talk about tonight because they take a little bit more time, and I don't want to take up the whole time. It's been great being here. But setting up two-factor authentication with SSH, it is possible. There is a tutorial on DigitalOcean.com where you can pick your Ubuntu version, and using PAM and the libpam Google Authenticator library, and you can basically set up multi-factor auth on your SSH to where you can use like a Google Authenticator or something, and it will, you can basically TOTP, and you can use that to, you know, have a secondary code to make sure it's actually you. That would be already using key auth, and then using that would make you very secure. And then finally, the last thing we don't really talk about, which is kind of that SOX proxy, is technically, if you really, really wanted to, you could build a VPN based out of OpenSSH. SSH supports building just generic tunnels that can pass all traffic protocols, not just TCP. So also like UDP. Also, this is not supported in PuTTY. This is not a good idea. This may be a good temporary solution, but it's not a good idea long term. When a TCP packet is lost, it retransmits. and then basically has exponential decay if it doesn't work. So when you wrap TCP in TCP, you amplify this retransmit thing. Like it could retransmit and then like retransmit twice for the price of one, and it just gets nasty. TCP based VPNs will absolutely collapse when congested. This is probably the most advanced thing you can do with SSH. Debatable. You can also run an SSH certificate key certificate authority with it. So most people use it to just log into something, and it can do all of this. And I hope that that through this you've learned something tonight. Yes. Well, okay, so Eric says a good niche for using remote forwarding, installing packages from PI, CPAN on a machine with no internet access. I mean, if it doesn't have internet access, how's it establishing the SSH connection? It may be blocked. Maybe you're on so this is great if you're on restricted networks. If they're not blocking SSH, which I disclaimer, I am not telling you to do anything at your job that is considered illegal or not fun to do. Don't do it. Just be a good person. That being said, the number one tool for getting around any of these tools is SSH. Because if you have developers at your company, you have to have SSH. At that point, anything that is blockable is remote port forwardable, and anything can be accessed. So, not a good idea. Yeah, restricted outbound access. Yes. So if you have SSH, you can get through anything, any form of like access control stuff, like or access denying stuff, like not letting you view something on the internet. SSH blasts through all of that. So it's a really cool tool. That being said, I have a couple of resources for you. OpenSSH.com is really great. The documentation is fantastic. SSH Mastery 2nd Edition by Michael Warren Lucas. This is where almost all of this talk came from. These are literally chapters out of his book. I was one of the first tech books that I read upon getting my first job. I absolutely loved it, and he's a great author. If you don't like this book, there are tons of books that he has written, but I cannot say like this is, if you want to do all of this and learn it all and more and have like just crystal clear, pristine instructions, it's a great book to have. And then there's also this tutorial on two-factor authentication with Google Authenticator and PAM. If anyone has any questions, please let me know. We can take like a minute. If you've never tried DigitalOcean before, you can get a free $100 free credit for 60 days by going to do.co/Mason. DigitalOcean is a cloud provider for developers and small businesses. It's a great place, focusing on simplicity. I love working there. It's a great place to be. So thank you, everyone. Hope I didn't go too long. And if there's any questions, feel free to drop them in the chat really quickly, or I'm about ready to drop off.
Okay. Yeah, I'm just waiting for a couple questions come in, Mason, with the 10-second delay or so. But I just, before we get any of those, if we do, I just want to say thank you again for coming out and talking tonight. Very informative. Cool to see you do the on-the-fly debugging there. That was pretty awesome.
It's funny because it was even on my notes. I just didn't read the next bullet point.
Yeah, I have the same experience a lot. Like reading the manual just seems to be way tougher than it should sometimes, doesn't it?
Reading the things that I wrote for myself so I wouldn't have to read it seems to be a lot tougher. Yeah, the thing is, I've like whenever I was writing this talk, I made a mistake. And I was using the server IP address here, and I sat here for 30 minutes just like, what is going on? Until I finally reread the manual and figured it out. So I've spent a lot of time debugging these errors, so I was like, oh, it's gateway ports. SSH can be infuriating, but it's also one of my favorite tools. So we have some.
Yeah, you obviously know a lot about it, and thank you again for sharing that with us tonight. All right, cool.
Awesome. Well, thank you for having me.
You got a lot of applause coming in from the audience here, but I think you probably answered everybody's questions. It probably more than a lot of people knew. So again, awesome. Thank you. Have a good evening. We'll take a short intermission here, and then we'll get Joe on for the talk. I'm going to put up this slide again for the for the raffle during our intermission here, which will take about 10 minutes. This is about 6, let's call it 6:40 right now. We'll come back at 6:50. I just want to read the proper verbiage here from our sponsor, JFrog. Our sponsor, JFrog, has a monthly raffle with ChiPy, and this month they have 3 Adafruit clues that are CircuitPython compatible. You can scan the QR code that's up on the screen now, or you can click on the link that I posted earlier. I'll drop it in there again to make sure everybody can see it. The winner will be selected in 2 business days, and then will be shared on the meetup page and congratulated on social media. So please do enter the raffle. We like having JFrog around, and they're very gracious to do this for us on a very routine basis. With that, we're going to just take that 10-minute intermission here. Thank you. All right, everyone. We're going to be coming back in just a minute or two, but I just wanted to remind everybody just one more time. Take that last 2 minutes here and go fill up the raffle. Make sure we get a bunch of people entered so we can have JFrog to continue providing that on a monthly basis. It's really cool that they do that. All right, our next speaker here is going to be Joe, and he's going to be talking about Mtls and Python. Hey, Joe, how's it going tonight?
Hi, good to be here. I guess I'll get started.
Okay, cool.
So my name is Joe Jasinski. I'm one of the organizers with ChiPy here. I also work at Nielsen, as in the Nielsen ratings, and we do a lot with Python and Kubernetes and other open source technologies. So we've got a lot of cool stuff going on. Let me know if you want to learn anything more about that. But over the past year or so, I've been working a lot with TLS and Mtls. And this is kind of a topic that I've been wanting to put a talk together on, and this is that talk. So, so TLS is fundamental to how the internet works, and so I think as a software engineer or a DevOps person, it's really useful to know kind of the basics, at least, of how TLS works. So this talk is going to kind of cover the basics of TLS, and then Mtls extends upon that and enables some really exciting enhancements. And I'm going to talk about that a little bit. And I have a working Python example of Mtls in action. So I'm going to demo that. And then finally, I'm going to just touch on how you can use TLS in the wild or with other software that's in use with it. So first of all, like, what is TLS? TLS stands for Transport Layer Security. It's basically the protocol that's responsible for securing communication on the internet and in private networks. And so, like, let's say you have an individual, Alice, who's trying to access Bob's web server. We want to Alice wants to guarantee that her connection is secure, that it's encrypted, no one's able to intercept the traffic between her and Bob. She wants to ensure that Bob is who she thinks it is, and not some imposter. And a third party, such as Charlie, shouldn't be able to read or change the communication between them. So this is where TLS solves all of these problems. TLS basically ensures encrypted connections, authenticated connections, and integrity-based connections. So encryption hides the data that's being transferred between two parties. Authentication ensures that the parties exchanged information are who they claim to be, and integrity verifies that the data has not been forged or tampered with. And so the most obvious thing that you as a user of TLS might recognize is the lock icon in your browser. That's kind of indicating that you're using a TLS secured connection. So I'm going to touch briefly on the history of TLS. TLS started back in 1995 by Netscape, and it was built into browsers since that point. And it's gone through a lot of different versions and generations, most of which are insecure at this point. Newer versions have dropped older broken protocols and encryption algorithms. And currently, there's only two recommended TLS versions, TLS 1.2 and 1.3. 1.3 is still pretty new, but it's supported by all the major browsers. And 1.2 is probably still the most ubiquitous, but that's quickly changing. TLS 1.3 adds a lot of new features. In fact, it was kind of a rewrite of a lot of the protocol that basically makes it more efficient and removes weaker algorithms. So one of the key features of TLS is encryption. How do we encrypt traffic between client and server? So the first thing, like the main thing we need to do is between client and server, we need to agree upon a shared secret, a secret that both the client and server know that no one else knows, that they can use to encrypt the connection. And so to get to this shared secret, we use two encryption types, asymmetric encryption and symmetric encryption. Asymmetric encryption is commonly known as public-private key encryption. And we use this to exchange, to generate and exchange that shared secret over the public internet. So the client is, the client and server are talking over an insecure connection, the public internet, and potentially neither of them have spoken with each other before. So some way, there needs to be a way to establish this shared secret across a zero trust network. And symmetric encryption is once you have that shared secret, then the client and server can encrypt and decrypt messages using that shared secret. And the reason why we use AES symmetric encryption for encrypting and decrypting data is because it's much faster than some asymmetric encryption. So just to kind of visualize what's going on here, symmetric encryption, you have a source and a destination, and both of which have a key that's the same. The source will have some plain text that it encrypts with the shared key. It goes over a public medium, and then the destination uses that same shared key to decrypt the message. With asymmetric encryption, the destination will generate a public and private key pair. It will hold on to the private key and never reveal that to anyone. And the public key will give to anyone who who wants to communicate with it. So the public key is public, obviously. And so the source, if it wants to send a message, it uses the public key of the destination to encrypt some data, and the private key, or the destination having the private key, will be the only person in the world that's able to really decrypt that message. Asymmetric encryption is also useful for digital signatures. So if a source generates a public and private key pair, then the source can share its public key with anyone in the world, including a destination. And then if the source sends a message, it will use its private key to sign a message. And then the destination can validate that signature to make sure that the message hasn't been tampered with as it's traveled over the internet. So that's just kind of the very, very high level of symmetric and asymmetric encryption, but both are very important in how TLS works. So to kind of summarize how these algorithms fit into establishing a TLS connection, you have a client and a server, and here's like a network protocol diagram. The client, when it initiates a request, like a web browser talking to a web server, will first generate a temporary public and private key pair. It will send the public key to the server. The server will also generate a public and private key pair and send its public key to the client. And in addition, the server will also send its TLS certificate to the client. And I'll talk about that in a little bit. And so now that both client and server have each other's public key and they have their own private key, that's enough information that it can generate a shared secret that only those two entities know, and they can use that shared secret to encrypt future communication, like the actual data of the connection. So there's a really good website here, this tls13.ulfheim.net. It really goes into a deep illustrated example of each step of this TLS 1.3 handshake. It's really cool if you kind of just want to take a look and see exactly what it's doing. There's also a TLS 1.2 version with a similar name, so it's really good if you want to just get a sense of what's happening in depth. So another really important feature that TLS offers is authentication. Basically, how do we trust that the server is who we think we're talking to? So like if I'm making a request as a client to chippy.org, I want to make sure that I'm actually talking to chippy.org, not some imposter that's like capturing my traffic and forging forging itself as chippy.org. So we do this with TLS certificates, and certificates basically contain the domain name, domain name of the server that you're trying to connect to. And this is called the subject field. It could contain the domain name, location, and other important information. And a TLS certificate is basically a public key that's associated with a private key on the server. So the server has its own private key, and the TLS certificate is essentially a public key with some additional metadata about it. That metadata is signed by an authority or certificate authority, and that certificate authority is like a third party that's trusted and says, I validate that the domain name in the certificate actually refers to this server that holds the private key that's corresponded with this the certificate. So yeah, again, a certificate authority is a trusted third party that signs TLS certificates and basically guarantees that the certificate belongs to a specific domain. And a certificate authority also has its own TLS certificate. So its own TLS certificate is used. It's a public certificate that's used to authenticate that the downstream certificates that it issues and signs are valid certificates. So here we can take a kind of a diagram of how this works. It's known as the chain of trust. So when you make a request to a server, you get back the server's TLS certificate plus the certificate of any intermediary certificate authorities that have signed the server certificate. So then the web browser can check the server certificate and say, oh yes, this is the domain I'm trying to connect to. This intermediary certificate signed the server certificate, and then this root certificate signed this intermediate certificate. Now, root certificates basically are where the chain of trust ends. It's like they're implicitly trusted, and they're implicitly trusted because the root certificates are shipped and baked into your browser. So there's maybe a few dozen root certificates that are entities of high trust, like VeriSign or Microsoft, or a number of different other entities that are highly trusted, have really secure certificates, and then issue delegate trust to intermediary certificates, smaller entities that issue TLS certificates, and those smaller entities issue certificates for individual servers and customers. So a certificate authority could be a public organization on the internet that sells certificates. It could be something like Let's Encrypt, which you can get free certificates from. It could be an internal corporate network that has its own certificate authority that issues certificates. So if you can kind of take a look at what's happening in your browser. It's kind of nice. So like if we go to chippy.org, we could take a look at this certificate by clicking on the lock icon and clicking on more information and clicking on view certificate. And we'll see here that the chippy.org is issued and signed by Let's Encrypt, which is also known as R3. If we click on R3, this is an intermediate certificate authority. This is signed, issued by the Internet Security Group, aka ISG Root X1. So if we click on that, then we see that this is a root certificate, which it's issued by itself. So that means it's a self-signed certificate. So it validates its own trust because it's at the top level of that hierarchy. And so the root certificates, as I mentioned, are installed in your browser. So if you go to privacy and security and you take a look at the certificate section, you can see here, these are the list of certificate authorities that come shipped with your browser. So if that chain of trust ends in one of these certificates, then your browser considers the whole connection secure. So that's the gist of that. Oops. So again, just to nail it in, here's your browser downloads the server certificate and any intermediate certificates, and then the root certificate is installed in your browser, and so each of them validates each other up to the root. So let's take a little demo of how this might work. So this is an example of how a certificate authority chain of trust kind of looks like on the internet. I'm going to actually, mind if I make the screen full screen here, just so, because it gets kind of small. But for this demo, we're just going to simplify this. You can have a chain of trust that's as long or as short as you want, but for this demo, we're just going to have a server and a root certificate authority. And basically, I want to show you the interaction of what happens when you create a certificate authority, if you're creating your own, for example, and the interaction of how you as a server get a certificate issued to you. And so we do this with we can use the OpenSSL tool, which is a very popular open source toolkit for doing cryptographic functions. And so this can be the tool that is useful for generating and signing certificates. I'm also going to show you alongside us doing this with Python. There's like there's a Python package called Let's Encrypt. No, I'm sorry, not Let's Encrypt. Cryptography.io. And it's a very popular Python package and very powerful. That it's like a cryptographic library for doing various cryptographic things. So I'm going to show you kind of this demo doing both at the same time. So the first thing we need to do in our demo here, in our fake certificate authority, is we need to generate a server key for the CA itself. And we do this with this OpenSSL command, which we're saying I want to generate a 496-bit key using the RSA algorithm. I'm going to save it out to this root ca key.pem. And here's basically us doing the exact same thing in Python. And then we need to generate a certificate for that root certificate authority. And we do this with, we generate a little configuration file that basically says, I want this certificate to be a CA certificate. And I'm going to specify the name of my certificate my organization is myroot.com. And I'm going to issue this certificate for 1,000 or 10,000 days because we don't want this to expire anytime soon. And as an input, we take the private key of the CA that we just generated, and as an output, we generate the certificate that's designated here. So here's the same thing in Python, or very similar. We're adding a little bit more metadata. And so we can kind of view what's inside of that certificate. First, we can see the issuer, or the issuer it's a self-signed certificate. So the issuer is the same as the subject. The subject is like the identifier for the certificate authority. And this is indicating that it's a 4096-bit RSA key. Here's the key data, and then this is the signature, the self-signing signature for that certificate. And so now let's say we want to generate. Now that we've established the certificate authority, we've created a certificate authority essentially. Now we want to like simulate creating a server, and the first thing we do for that is we generate a private key for the server using the same command we did before. Just we're running it on the server this time. Again, here's how to run it in Python. And the key might look something like this with this PEM header and footer that includes the key in the middle. And then if I want to view the server key itself, like you can take a look at this is like the cryptographic details of the server key. It's got a modulus, an exponent. This all kind of boils down to the RSA algorithm, and it's kind of really interesting to learn more about. I'm still pretty new to the individual components of this part, but it's you can kind of see the inner workings of how the key is laid out. And then the next thing we want to do is create what's known as a certificate signing request. So basically, we're creating like a little certificate signing request bundle that says, here's my public key, here's the metadata about my server that I want you as the CA to sign for me. And so in the certificate signing request, we define the name of the server. In this case, we'd call it chippy.com, and we can give it some alternative names, like I also want to have a valid certificate for www.chippy.org or any subdomain of chippy.org. And I want it to be a 49-bit key. And then I use my, as an input, I provide my server's private key. And as an output, we generate the certificate signing request for that key. Or for that key. And here's, again, a similar command, doing it in Python. Let's see. So next, we send that certificate signing request to the certificate authority. And the certificate authority basically takes its private key, its CA certificate, and the certificate signing request that was provided to it, and it signs that certificate signing request and generates a TLS certificate. And then that TLS certificate is sent back to the server. So here's what the CA is doing when it's signing that certificate. It takes as an input, again, it's the certificate signing request that was sent to it by the server. It takes its own certificate, and it takes its own private key, and it generates an actual certificate file here. So again, we can see what the certificate looks like. This looks very similar to what we saw before, except the main difference is that the issuer is, instead of being a self-signed certificate, the issuer is the CA's information. But the certificate itself is identified as identified as chippy.com. So, and again, here is, let's see, maybe it was in this one. Well, like I don't think I have it in this example, but essentially the subdomains and such can be embedded in this as well. So once the certificate signing request has been created, or once the certificate has been created by combining all of these components, the certificate is sent back to the server. And in addition, the certificate authority also sends back its own CA certificate. So then, as I showed you before in that other diagram, you can take that CA certificate and then validate that the server certificate is was indeed signed by the CA certificate. So that's kind of the very technical approach, demonstration of how this works from a process level, I suppose. So that's all really interesting and useful. That's how most of the internet works in terms of establishing trust with TLS certificates. And Let's Encrypt kind of automates that process, so you don't have to go through that issuance, which is really time consuming and cumbersome sometimes. But Now I'd like to talk a little bit about MTLS. MTLS stands for Mutual TLS. And whereas in TLS, the client authenticates the server. So like as a web browser, you're authenticating that you're talking to www.chipy.org. But in MTLS, both the client and server authenticate each other. So if you're a client, you have a specific name given to you, the server would establish at the TCP level that you are the client is who it says it is. So, and the way this works too is that the client and servers all share a common ancestor, a common certificate authority that validate those certificates on both the client and server side. And so the certificate authority signs the certificate, the identity in the certificate using the subject field or the subject alternative name field. So here's kind of an example of what we were seeing before, how TLS works. You have a CA that issues a certificate to a server, and then the client requests that. Well, in MTLS, you have both the client and the server receiving a certificate, which then their identities are baked into that certificate. And then when you have an encrypted connection between them, each side knows who the other side is because of those identities. And so I created a little like Django app to demonstrate how this works. And I think it's this is kind of the architecture of that app. And first we have like a simulated root certificate authority, and then we have a browser, and then the Django web app is over here, and that certificate authority issues a certificate for the browser, and the certificate authority issues a certificate for the web application. And this web application is running a simple Nginx server, and the Nginx server terminates the TLS to the TLS connection. And it also, like through this connection here, or through this connection from the browser to the Nginx server here, Nginx can identify that a request is being made by the browser, and it can parse out this name from the browser and then use that as an identity for the connection. Then it could pass that identity, that name, to through like a normal socket, reverse proxy socket connection back to a Django application, and then the Django application can authenticate the app using that identity. And this TLS connection between the browser and Nginx, is the keystone of that trust. And so once it hits Nginx, it's considered a trusted, like the connection can't be forged because it's a cryptographically secure connection. And so you have an identity at this point at the Nginx server. So here's like here's a example of how this works. So I have this this app. Actually, all the code for this is posted on my GitHub account under this Nginx MTLS prototype demo, and I've got a little bit of a description about how it works. But basically it works kind of like this. Let's see here. This and annotation's taking a second or two, but so first thing I want to do is like I'm going to make a bunch of certificates. So right now I'm generating a bunch of certificates using kind of like a similar example to what I showed you in the Jupyter Notebook just a few minutes ago. It generated all this junk here, these root CAs and server CAs and client CA certificates and CAs, or client certificates and such. And it's doing so just running some OpenSSL commands like I was demoing before. And then so basically when our request comes in to this application, actually, let me run the app first. A request comes into this application. It hits this Nginx reverse proxy here, which is a pretty standard Nginx configuration example. But the biggest thing here, like, so here we're setting up the TLS protocols. We're saying we only want to support connections with 1.2 and 1.3. We're setting the TLS ciphers. And then this is where we say I just generated some server certificates that are signed by a common certificate authority. This is a pretty standard, like if you get a TLS certificate issued to you by a certificate authority, this is the common stanza you use in Nginx to indicate that. But kind of the real crux of this is this configuration line here, this client, this SSL client certificate configuration. And this lets you specify the public cert, or the CA cert, the certificate authorities certificate, that will be used to validate incoming requests. So this is kind of like the key of that. So this certificate is, again, the certificate we saw before, this CA certificate that's going to be paired with it's going to validate the client's certificate that gets sent to it. So in addition, we have some headers that get sent. So this is kind of a key portion of what we're doing here is these headers like parse out the certificate, the TCP connection that's established between the browser and the Nginx server, and it parses out the identity from the subject alternative name in the subject, and it sets a header that includes the identity of the client. So these are the headers that get used in that get used in the Django app to identify that the server or the client is who they say it is. And so again, at this point, when it hits Nginx, it's already authenticated because the certificate, the fact that the certificate is a valid certificate indicates that the certificate authority authorized that client to connect to the server. And so the rest of this is pretty standard Django boilerplate, or Nginx boilerplate to talk to a Django app. And then another key component of this is this authentication backend for actually it's a middleware, but basically it says I have a header, or like I'm looking for one of those headers that's sent by Nginx, and I'm going to find the identity, like the username that's inside of that TLS certificate, and I'm going to like use that as the username for my Django application, in which case then everything else is just like normal Django authentication behavior. So here's kind of an example of how this works. Like, let's say this is the website that I'm running locally here on HTTPS localhost 4033. If I refresh the page, you can see it's unauthenticated. But then if I install the client certificate in my browser, basically, so when I make a request to the server, the certificate is included. I can do this by going to settings, privacy and security, and I can view my certificates, and I can add a client certificate. And now if I make a request to this website, that header, that the connection will be encrypted over MTLS, and that header will be set by Nginx, and Django will be able to like parse out that header and use it to log the user in. And so actually this might not work because I have some caching. So if I do this with an incognito window, it will make sure it hasn't cached my my certificate. But if I make a request here, it asks me, oh, hey, I know this. You're trying to make a request to a server with a common certificate authority, and I have a certificate that's been installed in the browser that I can use to connect. So I say okay, and because my local host isn't signed by a root certificate authority, it gives me this security warning. But if I accept the risk and continue, oh well, there's the. I guess that wasn't supposed to happen. But what you're supposed to see is this right here. I'm sure the demo guards are not with me today, but essentially this would be the response that I would normally see. So anyway, you can download this app and play with it yourself and kind of see how it works as a working example. But the next thing I would talk about a little bit is the applications of MTLS. So what I'm just showing you here is like a lot of setup and a lot of administrative to kind of get this system, a lot of configuration to get this system working, to get like a client certificate that's issued by a certificate authority and a certificate that's assigned by the same certificate authority. It's very complicated to do that, and so normally you wouldn't see this on the open internet. You wouldn't. It wouldn't be practical for any visitor of a website to install the like a public certificate for that website. But where it is really useful is in corporations or clusters of microservice applications, because you have like a common scope of servers that can all owned by a single organization, and that organization can have its own certificate authority that can issue certificates to each entity, to each server inside of its own network. And there's tools called service meshes which automate this process. A service mesh, there's a service mesh is basically an application that intercepts traffic between different web applications, and establishes an encrypted connection between each service. Like some examples are Istio, Linkerd, and Open Service Mesh. And so, for example, if you have like a service mesh, such as like this representing a service mesh here, and you have a number of apps running inside of it, you can have a certificate authority that issues a certificate to each application, and that certificate for each application would have that's application's identity baked into it. And so all traffic going in and out of each application is redirected through this sidecar proxy as on its way to another application inside of your service mesh. And the sidecar proxy establishes an MTLS connection between each service, and it can say, like, app 2 can say, I understand app 1 is connecting to me, or I understand that app 3 is connecting to app 2. And you can even set policies to say, I want app 1 to be able to talk to app 2, but I don't want app 3 to talk to app 2. And you can set these policies at the TCP level and without having to make any changes to your application at all, just to your service mesh. Your service mesh is what configures this. And so, like, the service mesh is a very deep topic, and Istio is the one that I've been using a lot for my daily applications, and it's very powerful and interesting. But it's its own talk in itself. But Istio is a service mesh for Kubernetes that lets you do a lot of meta management on top of your web applications inside of a cluster, a Kubernetes cluster, typically, such as traffic monitoring or access control using MTLS, and just it encrypts every connection between every service inside of a cluster. So I'm not intending to go deep into the subject, but I just wanted to kind of show you how MTLS is used kind of in kind of a modern setup. So with this talk, we've learned a little bit about how TLS works. We've talked a little bit about MTLS and how it extends TLS. We saw a mostly working example of a Python Django web app using MTLS. And we've talked a little bit about how service meshes enable MTLSs in modern web applications. So if you have any other questions, I'd be glad to talk with you or answer them during the chat, or talk with you at the Gather Town meeting afterwards. There's some cool resources here that that you could take a look at with some of the links to what I was talking about, including the demo app. I'm disappointed this app didn't work. I'm sure it was working like this morning. So there you go. We can try it again if you want to meet me at the Gather Town. But thank you for your time and attention, and reach out to me if you have any questions.
Hey, Joe. That was a great talk. Thank you. You got a lot of compliments in the chat here on the slides and just the overall quality of your presentation. We did have one question here from Daniel. Was how does the CA know that it's signing a certificate for the owner of the domain?
So that's a good question. So that's done in a number of different ways, but like a common way that it's done is, so let's say you're a website owner, and usually what you'll have to do is prove that you own that domain. And there's two ways that you can do that typically. One is you can, like, the certificate authority will say, enter this like random string that only I know into your DNS record. And then before I issue a certificate, you'll send me your certificate signing request. And before I sign that request, I'll have to verify that random string is in the DNS record that I expect it to be. So thus proving that you own that domain. Another way you can prove ownership is sometimes the certificate authority will say, I want you to host a file, like this random file, like with a secret string in it, somewhere on your web server that in a location that I specify. And then if I'm able to reach that as a certificate authority, if it can reach out and access that, then it knows that you were able to own the root of the domain such that it can it can trust that you are the owner of that domain. And Let's Encrypt does that kind of in an automated way. So that's a really nice tool for automating this whole like back and forth that we kind of went through manually in this example. What's the J stand for? Oh, John. A request in the chat there. Is there any other questions? All right, well, thank you very much.
All right. Thank you, Joe. That was a really high quality talk there. I'm going to just switch back over to the ChiPy slides and invite everyone over to the after party. All right. So yeah, that concludes the meeting and the talks, obviously for the night. We'll have an after party in ChiPy.town. If you want to show up, please do. Joe will be there. I'll be there. If you have any questions or follow up on site, or just want to talk programming, Python in general, or whatever, I'll look forward to seeing you there. Thanks.